We're in the process of reballing these modules and the GPU core, as you can see here, for this RTX 4090. And I thought I would just quickly outline how we do that with this reballing jig for both the modules, and if I have the time I'll quickly do the core as well. So I've already done the first batch of modules, as the 4090 actually has 12, the jig supports 9, so we do 2 batches, which gives us 18, and we've already had 2 of those done separately, so we should end up with about 16 chips in total by the end of this process. So all we're doing now is adding them to the jig one by one. So what happens is they get planted down. There's no need to add any extra flux to the backside of the chips. They should hold in just fine on their own. With all of the modules sitting nicely in place, and we make sure that the modules are clean and tidy, so we give them a quick wipe before applying any flux. That's me just drying the jig quickly. You don't want any leftover isopropyl or cleaning fluid in between the chips, because when you do come to apply the flux, you don't want this kind of slippery mix of flux and isopropyl or whatever cleaning fluid you're using, as it will end up reducing the amount of flux that is on the chip and ruining things later on. Now, when it comes to flux application, you want to opt for one that isn't too thin and has a good viscosity to it. You want it to be effective in the sense that you only need to apply a thin layer for it to do a good job. If your flux is evaporating very early in the reflow process, this can cause many balls to form incorrectly and requires additional flux at the end of each reball, which is a bit of a headache, especially if your flux is hard to clean. We also find that with those types of fluxes that the residue is quite stubborn and very difficult to clean off. The flux we use here, it's Alpha OM338. It meets most of the requirements when it comes to the application, removing oxides, wetting, and if it comes to it, cleaning any residue following the reball. That's even once the flux has settled at room temperature. On to the next step, we're going to have a look at the application of flux that has just been done now, and we're going to see if it's too much, too little, and if anything needs to be adjusted. Having a quick look, to me it seems that there is not enough flux on the chips, so we're just going to add a bit more and spread that again. Quick note, while we're spreading the flux, we are not actually pressing down fully on the chip and then pressing the flux down from one chip to another. Rather, we are gliding or pressing the chip just about enough where we can feel it and spreading the flux that way. Otherwise, you're going to be carrying or pushing the flux from one chip to the next while the other one goes dry and the other one gets too wet. With the application now complete, we're going to do one more inspection of the flux, and if I'm happy, we'll carry on. If not, we'll go over it one more time. Looks good to me. There's a cold joint that I've just spotted, so let's just scratch that quickly so that doesn't interfere in the process later on. And with that, it's time to plant the balls. Sweet. Back to the top view. We're going to grab the top of the jig, place that right on top. Make sure everything that aligns well, and as you can see, everything looks great. Grab off 0.45mm solder balls, sprinkle them right in, jiggle around the jig. These solder balls should fall into the respective places, however we do like to go the extra step and just pull them down with this little tool here. Again, just like when we were applying the flux, we are kind of gliding and very lightly touching the stencil, ensuring those balls go down, and if there are any double balls or balls stuck on top of each other, this will bring them down to the bottom of the stencil right away. Happy with that? So now we're grabbing the jig and very carefully lifting up from the modules, as the modules may stick to the stencil. Unfortunately, the tolerances on this jig aren't amazing. And so what we do is we lightly lift, and if we see any modules stuck to the stencil or any balls, we will bring them down with that same tool. And as you can see here, thankfully no balls were stuck, however some of the modules were sticking to the stencil jig, so we were just pushing those back down as you can see here. All the balls go back into the pot, and as you can see, that's looking beautiful. All the balls are planted onto the chips, the jig can go away, the stencil is clear and free of any other solder balls. That will be cleaned once the chips go onto the heat mat. And here we are, just removing the chips from the jig, going straight onto the heat pad, which will be set to about 125 degrees Celsius. So let's have a look now at what the modules look like under the microscope, and now that they're on the heat mat. So as they're slowly heating up, we'll have an inspection first, clear up any solder balls, move them into the right place if need be, and if we have any extra time, we'll go ahead and clean the stencil jig and our working mat. As you can see, the balls are looking almost perfect, but now we have to inspect that for each module because there can be some misaligned or slightly, off the pad, as you can see here, just at the top there. Pushing that back into place, and we'll continue to do that for the rest of the modules. Just found a cheeky little squished ball here, so we'll quickly remove that, put a new one on, and move on to the next. Having a look at the rest of the modules, everything's looking pretty fantastic so far. With that, the heat mat is now at about 80 degrees Celsius. We'll let it reach about 115, 120 before we start with the top hot air. Let's see if we can get a better look here. Yeah, that'll be best. With the temperature of the heat pad now closer to 125 degrees Celsius, we're going to come in with the top hot air set to 15% and 335 degrees Celsius. We're starting off in small circular motions and then we're gradually closing in, so give it about 10 to 15 seconds, and then at the end of that process all the balls should melt nicely. And now we rinse and repeat. Having a look at this one, this is a good example of one that doesn't have enough flux, or it's evaporated during the preheating process. So in this case we will add some more flux at the end. Not so big of a deal. It'll take about 10 to 20 seconds to clean later on. This one's alright. Finally, here's another chip that needs a bit more helping of flux, so we'll add that now, and happy days. And we're finished. Okay, switching you back now to the top view. Those chips have now been complete. We've got here a total of 16. With that, why not let's get started with the AD102 chip. We'll have that reballed and quickly outlined for you. The principle is the same. We grab the jig, we put the AD102 chip inside. Thankfully, this supports anything from the GA102s to the AD102s, and so same principle where we're applying the flux, we're spreading it. With the GPU chips or larger chips, it's much easier to actually get a feel of the layer of flux that you need and that you require. You can get away with not really getting a feel of the flux on the smaller modules or the chips, but either way, it always helps to have a quick visual inspection. Maybe you don't have to, I can get away with it as well, but just for that extra, how do you say, safeguard or extra measure, it's good to double check it with visuals, and then you can see if there are big blotches of flux or areas that are not actually covered in enough flux, so you can then adjust those accordingly. Sweet. Again, having a look under the microscope before we apply the balls. Looks great to me. Down in the middle. Fantastic. Looking all good with the flux application, so we'll switch back to the top view, get the top plate on. At this point, the reason I'm taking it apart a few times is for some reason, for the first time ever, after maybe God knows how many, maybe 30, 40 ultrasonic cleans on this jig, the top felt quite tight. There was nothing blocking it, there are no little solder balls or anything in the way, but for some reason it just wouldn't sit properly, which wasn't a big matter. Thankfully it would still sit, it just would require a bit more pressure and force when taking it apart. Not ideal, but you make do. So either way, I've put the top part of the jig on now. We're rolling on, this time 0.5mm solder balls, so slightly larger. You can see those go on quite nicely. The same thing, we use the same tool, brush it lightly in, just gets rid of any balls that are on top of each other, gets all the balls also sitting flat onto the chip in case they are slightly elevated. Unlikely, but it just helps, especially when you're working with hundreds or thousands of joints. It's good to minimize that, because again, if you have a 1% or even a 0.1% error on such a large scale, it becomes a headache over time, and again, builds up on wasted time as well. So lifting up the top of the jig, everything goes back in the 0.5mm pot. The jig is clean, like the last one. The chip is looking great, and we can put that on the heat mat. The memory modules are also cooled down now. The heat plate is about 35 degrees, so everything is cooled. We can take those off, put them in the pot. We'll clean the other ones later on. And yeah, we can move on from here. Let's switch back to the microscope again and have a look at the planting of the balls on this BGA chip. Looking so good so far. We'll do a quick inspection of the whole chip. Again, it's always important to realign these balls before things melt. And so far so good. Happy with the way everything's looking. Coming close to the middle of the chip, just moving in kind of a square motion. And that's perfect. We'll move back to the bottom right point of the chip and allow the chip to slowly heat up to make sure the whole substrate is at an equal level. You don't want to start heating up the top of the chip while the bottom is not heated up enough, or the middle of the chip is still reaching that temp. Otherwise you're going to overstress it. We'll leave this to play now. We're trying to keep everything here in real time so you can get a good idea of how long it takes to complete each part of this process. So compared to when working on the memory modules, the heat mat is set to a slightly higher temperature for the core. It's actually set to 145 degrees rather than 120, 125. And at this point, we then come in with the hot air. It's set to 15% on our 862D and 345 degrees Celsius. We come in slow circular motions. We do not point the hot air station at the bottom right corner of the chip just yet. So we're going round and round in circles slowly, kind of maybe 8 to 10 centimeters away from the chip and slowly closing in. That way, when we do come to the bottom right corner of the chip, you'll see how the balls go into place quite quickly because most of the substrate has reached that temp. And as you can see here, we've come to the bottom right corner, and within maybe 10 to 15 seconds, we should see the solder balls melt. So we're zoomed in now. As you can see, after kind of going around the chip, it doesn't take much time or effort to get those balls melting. The joints are forming perfectly here, and will slowly go across the chip. You can go in a diagonal fashion, you can go from top down. This doesn't matter too much, so long as, like I said, you start with that initial process. If you are starting from that one corner of the chip, you can get away with it, it's not a big problem. It's just not the best way for the chip to have those solder balls put onto them. Light in here. Perfect. So heat can come off now. You can turn off prematurely. Fantastic. Finishing up now. Having a quick look at the solder joints. Everything is looking perfect and ready to have soldered onto a new board. With the reball now complete, we're going to give the core about 10 to 20 seconds to cool down slightly. It should go down from about 185, 190 degrees to about 150, and then we'll slightly or slowly shift the core off the heat mat onto the side so it cools down a bit quicker and doesn't get exposed to so much heat for so long. Great. So with the core at about 110 degrees Celsius, we'll show that to you quickly. Everything's been complete. The modules are happy, the core is happy, and we're happy. We hope you enjoyed. Not the best video. I'm trying to kind of balance. I'm not the best when it comes to working and talking at the same time. So this is something I'm trying out where I'm trying to dub over the video. It's not the best, I understand, and there are a lot of blank spots. But yeah, forgive me, and I hope it's gone well. If you have any questions, let us know. We'd be more than happy to help. Take care and all the best.